I want to talk about something very, very evil. Let's do some very bad macros, shall we? Exciting, right? So imagine you're writing a program, and you're running into a problem where it's running a little slowly, and you don't want to have to optimize it. So imagine if you could wrap every single expression in your functions with a read-through cache. Now just hold on for a second here, because I know this sounds evil, but really it works. So let's write some embarrassingly parallel code. Right here we have Fibonacci, the usual, and we're gonna bigger. That good? Awesome. So we're gonna inspect IO inspect 1 twice in it, and using the function def on steroids, because I figured, give your code some steroids. We can jump into this. Bigger. That better? Awesome. And we can jump into this and run test.fib10, and bam, it prints 1 once. Why did it do that? That's because I used the AST as the key for the code and only executed IO inspect 1 once. What happens if I start doing something, expensive, like say, I don't know, 10,000, right? Make my computer purr for a second and then print it out. Pretty quick, right? Do it one more time? No time at all. That's the magic of caching. Please do not use this in production. So the basic code, as you can tell, is pretty simple. All we do is we call memoize on the body of the function when we rip out the body and override what we're supposed to be doing. And then whenever we have an operation, instead of actually calling the operation, what we do is we get or store in concache, a really cool library that lets you do this thing. But among other things, it gives you a read-through cache, which is really cool. So then we unquote the body inside as the function callback, and voila, we have memoization. Thank you, everyone.
Serious extra bonus points. 2 minutes to spare on that one. So for the speakers, your 4:30, your soft warning will be directly here in front of you.
Oh, is that my second screen?
So the next talk is going to be Boishan. There you are. Okay, nice.
I guess I can try putting it over there. There we go. Yeah. That's gonna be
Everybody
really
give Adam a round of applause.
Let's full screen it, maybe. Okay, that is very zoomed in. Okay, so in the line of doing bad things, I'm going to be talking about using and abusing Ecto. My name is Adam Bowen. I work at EJ4 LLC. That's my Twitter handle. Just as a warning, the following may be a very bad idea. So imagine that we have a third-party defined JSON API specification for works of art. And I say third-party so that you don't tell me that the way to solve this is to change how the JSON is structured. I can't. So credit where credit's due. I was inspired to change my example domain by Darren Wilson's talk today. So led to lots of frantic re-editing of my thing. So the JSON API structure, the data structures are well-defined but highly variable. So we're going to store that data in Postgres with JSONB. And so basically, a simple version of it is that we have a work of art which has a type, which defines its possible keys. All works of art have an artist. For example, an album may have a solo artist, or it may have a band composed of artists under a nested artist key. So examples of partial JSON documents to amazing works of art. Animal by Kesha and Love This Giant by David Byrne and St. Vincent. And that's also a really bad example of a band, because their name is like their names with "and" in the middle of it, but I did this today. So pattern matching in Elixir works great for this. We can break down validation into small parts. We can enforce more global rules and mess with headers and all that sort of stuff without having to drop down into Ecto quite yet. The change sets in Ecto make a lot of individual data structure work pretty easy. So this sort of helps me organize the validation rules into pipelines and provide great error messages. Embedded schemas allow us to validate different data types while keeping the structure in a single JSON-B column. And using embeds one and embeds many, I can sort of nest different structures within the data. So the basic schemas we have so far are, we have our work of art module with works of art as the table, and I sort of snipped the rest of this out, but we are embedding one data, which is the art data, which has a title, and then embeds one artist, which is a creator, and then the embedded creator, wait, I'm not sure that we can represent this with how Ecto usually does things, so, because we have multiple different types that can go into this embedded schema. So, what I want is some way to have two different schemas that can possibly fit into this one embeds or embeds one column. And so an example would be an artist that just has a name, or we have a band which has a name and then it embeds many artists. And unfortunately, it doesn't support polymorphic embedding. So like most problems in Elixir, I tried to pattern match my way out of this, but unfortunately you can't just like say that you're embedding many and then just give it a generic module and then try to pattern match in that and then do embedded schemas on those things. So then I discovered Ecto type and saw a path through. So if you're not familiar, you basically have to implement 4 callbacks to do an Ecto type properly. So for example, you have type, cast, load, and dump. The important one is going to be cast. So the solution's kind of gross, but here we're doing some pattern matching. We're detecting if we're an artist or a band, and then we're casting to a change set down here. And so now we have this solution. We do a field that is a type of creator, and now we can embed both of those. I have 30 seconds. Oh no, I have a minute, slightly. So issues is you cannot give a specific error message to the user because when you aren't valid with an Ecto type, it just says is invalid. And so possible alternatives might be using simple map fields and then validating the maps as separate embedded schemas, but that would be probably a lot of janky code also. And another possibility is figuring out how to replace Ecto type with something that can send error messages. I did a quick look into that, and it didn't seem terribly possible or easy. And the other one is convince the Ecto maintainers that adding a new return type to Ecto type is a good idea, which I'm not sure it is. So the conclusion is sometimes we need to build things that our libraries don't support. Sometimes the situation calls for bad ideas and bad code, and sometimes that's okay. And thanks. And let me know if I did something truly terrible, but because I really do want to know. So yeah.